Hi, this video is the continuation of getting started with FEDn video, where I have shown you how step by step you can build your first project from nothing to running multiple clients and run a federated machine learning environment using FEDn. So there I have covered quite a lot of details, but one thing that I mentioned there is related to the compute package. We have just quickly, in that video, we have just quickly prepared the compute package, but compute package is one of the very core component of the whole framework. And whenever you would like to create a new use case or want to make any changes in the available client-side code, the very first thing that you need to do is to make changes in the compute package. So this video is all about how to write or customize your compute packages. If you are not familiar with the previous video, what we have covered there, or if you are not familiar with the FEDn overall environment, I highly recommend you to first look at the first video where I have explained all the things and then start this. But last time we have covered the getting started with FEDn. This time the idea is to cover this develop your own project. Click on this and here you can get all the information required for the developing your own new project. So the very first thing that I think I would like to explain to you is the design philosophy behind how the client side actually works in FEDn. So as you can see that the client is just a wrapper that actually allows the environment for the training and the validation process coming through the system via the compute package. So you prepare a compute package, you upload a compute package to the server, and when the client get connected, it just get this whole package. Whatever is inside the package actually defines how the training, validation, and data loading process works. So the very first thing that is important, that how you prepare the environment. So this whole environment where your training, validation, and data loader scripts can run effectively. So there is one file, environment file, that actually defines all the dependencies. Once you start the client, the very first thing that happens is that it just go through with all those dependencies and install that and prepare the environment for you. The very next thing that happens is, like, you need to tell the client side that, okay, how the different processes will run. Like you have training process, you have validation process, how when there will be a command from the server side that, okay, now it's time to start the training, how the training process will start, which scripts need to be executed. So for that we have this FEDn.yaml file. So this file actually defines like what steps need to be taken. And then the compute package, as you have seen last time, contains these training scripts, validation, data loader, model, all the things that are required to define the client-side environment to run the training process. So this is basically the design philosophy. Again, client-side software is just a wrapper that allows the compute package to run on the client side. So that's the main idea. That's why every time for a new project, what you need to do is to prepare a new compute package, and once the compute package is available, client knows how to run the training process. Let's start with the FEDn YAML file. So here you can see that it's basically an entry point file where you can define when the command from the server side comes that, okay, start the training, how the client side should respond towards that command. So the idea is that in a simplistic Python environment, what you need to do is to simply run this command, python train.py, because this is the point where we have defined, or this is the script where we have defined the training process. If there will be a command that comes from the server side that, okay, now it's time to start the validation, python validation valid.py is the script that you need to run. And one thing that I think now you started to see in this script is that this is not really dependent on the Python specific kind of code. So what if I change this command to something else? Like, for example, my training process is in C++, Java, Ruby, Rust, Julia, any other language. What only I need to do is to change this command and define like how the training process should run. and also provide the environment and the dependencies that allow me to run the new command in that. So think about like if you are using a cross silo kind of environment where there is a possibility to run large packages and you can write all the fancy code. Sure, you can write that in high level languages, but what if you are preparing something for cross device kind of environment where maybe only the C is an option for you? So then you can actually, using FEDn client side scripts, you can just define your whole training process or validation process or the data loader process in C or C++, and then use the client based on the kind of code that you have defined in a different language. So it is very flexible in a sense that you can define whatever you want for your use case. And then, as I said, that what you need to do is to provide the right environment for the execution. So if we go down in this, on this page, what you can see next is that it also tells you like how you can check your different scripts before actually preparing the compute package. So the training script, what the example that we have used last time, when as PyTorch, it's a simple training script that's available there for the training process, and it takes the input model, means your seed model, and it generates the local model based on the training step. And for the validation, again, you need to provide some kind of model that you want to validate. Together with that, what kind of matrix that you want to generate from that. There is an example available on this page where you can see what kind of steps that has been performed in the example, both for the training and for the validation. And in the end, it also shows you like, okay, if you want to simply run the scripts that you have prepared, what are the procedures for that? So this page actually helps you to get all the details about how to prepare your own compute package. Okay, I think you are now very familiar with this interface. That's our studio, and the project that I used last time to prepare the MNS PyTorch example is already there. We will gonna use that and prepare another compute package that we will upload and work with that. So if I click on the open, I can go and all these information that we have basically prepared in the last 2 sessions are already there. Let's click on the session tab. You can see that both of the rounds that we have completed in the last video, they are there, and they both of these sessions are based on the compute package that is based on the already available files. And what we're gonna do today is that we will go make changes in the client folder, prepare a new compute package, and make it available on the server side. Okay, so with that, let's move to the command line interface. So same example folder that I'm using, MNS PyTorch, and here you can see that I still have 2 client files, and I can use this client folder to further customize my compute package. Let's go and open the files in the client side. So here we have all the files available. The very first thing that I told you is that we need to create an environment. So how compute package allow you to run the or create the environment? So it is basically in this Python environment file. Here you can see that the dependencies are there and also the kind of environment that you want to build. In this example, we are using PyTorch. Think about like tomorrow if you want to use another machine learning framework, maybe something else than PyTorch. What you need to do is to just define your new dependencies here, and the environment will be created accordingly. And also, very important when it comes to loading the data. We are using a very well-known kind of data set, but if you have a customized data set or something that requires extra libraries to read the data from the files, you can just define those kind of libraries here or those kind of packages. It will get installed on the client environment. So that is how you build the environment for your client side. Once you have that, the very next thing is that, okay, we need to define some entry points. And as I mentioned, entry points are in this FEDn YAML file. All the entry points are there. What you need to do, if you want to define something more, you can just make changes and then it basically defines like, okay, what's supposed to be happen on the client side when there is a signal coming from the server that, okay, now the training need to be started. Is it really something that is related to Python, or you want to write something else? All these things are something that you can customize according to your need. Okay, let's go and make some changes. There are two changes that I would like to make in my new compute package. First, I would like to change the architecture of my model. And the second is that I would like to change the hyperparameters in the training process. Here is the first file that I would like to update. That's the model.py, where I have the model architecture available. I have already prepared some statements that help me to quickly highlight the changes that I would like to do. So for example, currently there are 3 layers in this model. I just don't want to use these 3. I would like to use the first, but I can close this, this section and open up this 2-layer kind of model. This may not make much sense specifically when it comes to the MNS PyTorch kind of model, but these are the changes that will highlight that if you want to make any changes, how easy it is to do things according to your customized package need. And then on the forward side, what I need to do is to close these two and then just use the second layer. Yes, I think those are the kind of changes that I would like to do in my compute package model side. And then the next change that I would like to do is in the training process, where I would like to change the hyperparameters. So these are the hyperparameters available for my training process. Let's change it to something different. Let's say 20 epoch to 2 and learning rate a bit more lower. Yeah, so then my training process will be changed as well. So if I can do all these basic stuff that quickly, whatever changes that you would like to bring, these are also very easy to accommodate in this structure. Okay, so now we have all the changes that I would like to do in my compute package. One more thing that I would like to highlight here is that if you open the client folder and have a look on the data, you will understand that how we are actually downloading the open source data set and make it available to the clients. So if I open that, I can show you that, okay, this is the function, get function, that actually downloads the data. And then we have one function called data loader that actually loads the data according to the defined path. And then we also split the data on the client side so that the multiple clients can use different splits of the data. And if you don't want to use an external open source data set, what you only need to do is to open this file, make changes according to your local setup, and inject the data in the training process. And if I show you one more thing in the training script, is that this training function, the very first thing that this training function requires is to load the data, and this load data function is exactly that we have defined in the data.py file. So it's very simple, flexible environment where you can define and everything that is according to the demand of your local environment, and then make it available to the server side, and that's how the server push things to the client back. So now I have made my changes. I have one data.py script that allows me to load the data. I have made some changes in the model, and also I have changed some basic settings in the hyperparameters as well. Okay, so this is all what changes I would like to make. And now the point is that the next step will be to generate a new compute package that will be a customized compute package, and also a new seed model, because now I have changed the model architecture as well. Okay, and for that, if you remember on the this getting started with FEDn page, we have the command to prepare the compute package and seed model. We can just copy the command from here, go back, run here. It will generate a compute package based on the client folder where we have all our changes. So now we have compute package. The next thing that we need to do is to generate the seed model because we have a changed model architecture. So for that, I will copy the next line that is for the seed model creation. And yes, so this script basically requires to download the dependency, create a new seed model, and then both the package and the seed model will be available according to the new changes. So what now I will do is that I will wait for the script to finish. After that, I will upload the new compute package and the seed model in the system, start to clients, and make the setup available so we can just start the training based on our new changes in the compute package. If you are not familiar with how to start the new clients and how to upload the compute package, I again refer you to look at the previous video where we have explained all these steps. So now I have uploaded the new compute package and the seed model on the studio, and together with that I have also started the two clients with this project. Okay, I can show you first how the new session look like. So if I click on the new session, if I click here on the compute package, you can see that we have two compute packages. That's the old one, and the version 2 is the new one that we have created, and same as with the seed model. Now we have a new seed model here as well. Before I start a new round or a new session based on the new compute package and seed model, I would like to show you one thing that is important. So here, previously we have completed two sessions. In the first session, if you see, we have a seed model, initial model, and based on this initial model, we have prepared 5 models. The last model that we have prepared was this. The ID starts with 5A8. And if I go to the second session, you can see that this 5A8 is the initial model for that session, and that's how you prepare the next 5 rounds. Now, since we have changed not only the compute package but also the seed model, what will happen is that this connection that we have seen in previous 2 sessions will break. Now the training will start from a new seed model that now I have prepared, right? Let's go start a new session with the new seed model, new compute package, and see how things progress. Click here on the new session. We have a new compute package, we have a new seed model, and I need to define the ID. Let's say 3, 5 rounds, 180 round time. Let's start the session and see how it will go. On the client side, I can see that now the clients have started the training according to the new defined settings, and yeah, it will take few minutes or couple of seconds to complete the whole session. But what we can do is that we can go and see the view, what is happening. Yeah, clients have started to respond. Round number 11 and for 12 have started, 11 is now finished, and that's how things are progressing. But here you can see that we have a new seed model, and that's the model that is based on the kind of settings that we have changed in the model.py file. So this model is different than the previous models, and that's why when you click here in the on this model section, you can see that now there is no connection between the previous sessions and this session because we have changed the seed model. So here you can see that you have model trail for previous sessions, but then from this point onwards you have a model trail based on the new seed model that we have provided. So that's how things are logically connected, but everything that has been executed previously is saved and available. So you just need to click on the session, and if you want to go and see what happened or how the training was based on the previous compute model, compute package and seed model, you can click on the view and you can see all the models available here. Test accuracy, test loss, training accuracy, training loss, everything is available here. So yeah, that's how it is. Now the session has been completed. We can go to the model section and see, yeah, the 5 rounds has now they are complete. and we can see the test accuracy accordingly. So this is what I would like to highlight. It's a highly flexible and customizable kind of environment. You can define your own compute package. Defining a new compute package is not difficult, but I think the easiest way is that if you start with a new with a example provided in the GitHub repo. Uh, Start from that point. Start making changes according to your use case, and then finally build your own compute package that is according to the use case that you have. So that's how it is. Not very difficult. So.